there's been a lot of good, you know, news about the power of Gen AI and LLMs and things like that. ChatGPT has taken over the world and is being applied to every possible use case. And you see these kind of cycles happen with AI as a field in general, where um, some huge model will come up, some huge breakthrough, people will think can be applied to anything in the world. And then what happens is, you end up finding, okay, maybe it's not usable for everything, and maybe not, it's not going to make world peace or anything like that, but it has some really great applications to specific domains.
Okay, so welcome everybody to another data-driven podcast. And today I have a special guest. Our special guest is Jeff Curran, who's lead data scientist at AtScale. And I invited Jeff on the podcast because he's got he did some really important research. And everybody talks about Gen AI and how important Gen AI is to sort of our everyday lives. Well, it's also really important to businesses, and so we're going to be really diving into how can we apply Gen AI to actually help facilitate answering business questions. So, Jeff, first of all, welcome to the podcast.
Yeah, thanks for having me.
Jeff, I always like to start these things out just by letting the listeners know a little bit about yourself and sort of how you ended up being a lead data scientist at AtScale. So can you tell us a little bit about your path?
Yeah, of course. So I've been with AtScale about 2 years now. Before that, I was a data scientist at a large financial firm, helping stand up the data science teams from scratch. And what I saw was basically I spent about half my time getting to do the data science work, but half the time was spent in meetings with folks trying to redefine these business definitions and make sure all of the features I was including in my models actually matched up with what they were using in their day to day. So when I was thinking about moving back to Boston, I stumbled upon AtScale and saw that the semantic layer as a whole actually solved a lot of the issues that I was seeing in my previous role. And I thought, it had a great application for not only the BI tools, but also these data science use cases. So, I joined up the team, and it's been a great time ever since.
Yeah, as listeners out there, AtScale, we provide a universal semantic layer for businesses, and so we're really focused on BI. But as of late, the worlds of business intelligence and artificial intelligence have sort of crossed paths. And traditional BI, which is sort of a hunting for the needle in the haystack, is a sort of outdated way of doing BI. And I think the future is clearly combining artificial intelligence with business intelligence to make users much smarter, allow them to do their jobs faster. So, Jeff, you just sort of made some news here because you just released an important white paper, and the white paper is called "Enabling Natural Language Prompting with AtScale's Semantic Layer and Generative AI." So you led the research on this, and it's really focused on how can you take an LLMs out there and really give them business context so they can do a better job at answering business questions. So can you talk a little bit about sort of what sort of made you want to go and explore this and run the experiment so that you could actually write this white paper?
Yeah, definitely. So there's been a lot of good, news about the power of Gen AI and LLMs and things like that. ChatGPT has taken over the world and is being applied to every possible use case. And you see these kind of cycles happen with AI as a field in general, where some huge model will come up, some huge breakthrough, people will think can be applied to anything in the world. And then what happens is, you end up finding, okay, maybe it's not usable for everything, and maybe not, it's not going to make world peace or anything like that, but it has some really great applications to specific domains. And what the current realm of, generative AI models has kind of found out to be good at is, generating novel text from inbound user prompts. So think about this as, the text autocomplete on your phone just dialed up to 11. Instead of saying, it can suggest one or two words, it might be able to write an entire paper based off of the user's inbound question or prompt. But in our case, it solves a really interesting pain point that we've seen in the business as a whole, or just businesses as a whole, where someone wants to gain access to their business's underlying core data. Traditionally, for anyone that's not super tech savvy, that requires them to go through, say, a business analyst or go through a BI tool to act as kind of an interface between the question and this underlying data. And as I was just saying before, LLMs are really good at translating from one body of text to another. So the idea was, can we get an LLM to translate a natural language question into a SQL query so that it could actually access these underlying tables directly? So kind of let people directly interface with their underlying data without having another human element in between there. And this is something that has been explored in a couple other white papers. But there's been some significant drawbacks that have been hit in the past, specifically around understanding, business KPIs or key performance indicators. These things are hyper specific to the individual businesses, maybe even the individual teams. And if you ask, an LLM, what were my quarterly sales by team, it's going to just generate something that it thinks satisfies those conditions based on its training set. It's not necessarily going to use your team's definition. So LLMs,
because Jeff, right, these LLMs are trained on sort of the internet. They're not trained on a company's own data typically. So how would it know what a team meant to
exactly.
a Procter and Gamble, for example? Or what does it mean? What is gross margin? How do you calculate that for business A versus business B? It's going to be completely different, given the context of the business. So it's sort of taking sort of like a general approach, a ChatGPT approach, which has been trained on really generic data that's out in the ether, can't really work specifically for a particular business. Is that what you're getting at?
Exactly. Yes. These things are generative and generalized when they're out of the box. They are really good at dealing with things based on this massive training set they have off the entire internet. But when you want something hyper specific to one use case, you need to give it all the context relevant to solving that use case. And that's where, something like a semantic layer that provides all that incredible context in a way that's consistent to the business really can provide value to the LLM.
So it's even kind of harder when you get to querying databases, right? Like your Snowflake or your Databricks or your BigQuery, because not only do you have to figure out the business context, those business definitions, those KPIs, but you also have to construct a query against random tables that, again, every business is going to store their data in a different way, in a different set of tables with a different set of relationships. So you kind of even really amplify that problem of not just sort of terminology, but also if you got to generate a query, how do you make sure you're querying the right tables to come up with the right KPI?
Exactly. Yeah. So you're not only moving from a business term to, say, a warehouse term, which maybe, how you and I talk about, say, our business teams or something like that, might have a completely different column name that it maps to on the underlying warehouse. And without context, the LLM's never going to be able to make that jump or not be able to make that jump consistently. And then it gets even more complicated when you start dealing with multi-table operations where joins are required or complex aggregations. These things that require very specific join methodologies and join paths to create the correct answer. So again, this is something where LLMs struggle.
And you use the word correct. So if I'm going on ChatGPT and say, give me an agenda for my outing in Rome, Italy. If it's wrong, it's not the end of the world, right? But if I'm a CEO asking for what was my gross margin this month versus last month, and I go into a board meeting and it's wrong, the consequences are much more acute. So really, it sounds like we have the problem of how do you define a KPI from a training set that's been not trained on your data. We have an additional problem of how do you translate that into a database and database query where each database and each company's database may look completely different. And then we have the problem of accuracy because, business questions, if you're going to be making financial decisions, they better be right because the first time they're wrong, you're likely to be looking for another job.
Exactly. Yeah, exactly.
Okay, so talk to me a little bit about, what you did in this white paper. So, I think much credit goes to, I mean, we've had the feeling that business contexts need to be combined with an LLM to really make natural language query work. It's amazing, and it's been always an amazing sort of uh, true north to allow users just to use, English to ask a question of their data. That's always sort of been the goal, rather than having to point and click and do all these other things. It's so much more natural, and it opens up data to so many more people. But the fact is like those three problems we mentioned have been a big barrier, and it really took like Juan Cicada on Data.World did sort of the first sort of paper where he combined and did a test that combined or that compared a LLM answering doing text to SQL versus an LLM with a semantic layer doing text to SQL. And he found a big benefit. I mean, he found that there was a big lift in combining semantics, obviously, with the LLM. So, how did your sort of methodology and how does this white paper that you authored, how does it differ from that previous analysis?
Yeah, yeah. So it differs in a few key areas. The first one is just going to be the data set that we used. Um, the data set that we used for our white paper was just a little bit more fleshed out than what was done in the data.world paper. So we used the TPC DS set of tables. So it's about like 24 tables, a few 100 million rows. And the idea there was that if we were going to do a stress test against this, we really wanted to use, an example of data that's been vetted by the industry and used for a number of other benchmarks in the past. Not only that, but this data comes preloaded on, I think, most Postgres instances and a ton of data warehouses across, the industry. So if we want to be able to recreate this and give it and let people test this out on their own, we want the data set to be easily available. So that was one of the differences that we used here. I mean, the second big one is that instead of using, the data.world knowledge graphs and things like that they use for their semantic layer, we use the AtScale semantic layer, which provides a few key benefits. Just one being its own semantic layer definition, and two, in that it can interface directly with the AtScale query engine. So where the data.world paper had to deal with complex join operations and things like that, we were able to leverage the AtScale query engine and basically completely remove the need for the LLM to ever define both joins and KPIs. So measures, aggregations, things like that. So we drastically reduced the scope of the questions that we're asking the LLM by leveraging AtScale's existing technology. And we also were able to provide it the great metadata that comes from the semantic layer. So enabling the LLM to map between those human readable terms and how those objects are defined within the semantic layer. So
Okay. So this is recap here. So it sounds like, you solved two of the three problems that I mentioned. So you solved the problem of how to define a KPI. That KPI is being defined in the semantic layer. And then it's like, well, how do you then turn that user query into a query against a complex schema? Well, it turns out the semantic layer does that mapping, doesn't it? So, and if you use the query engine of the semantic layer, all those relationships are already defined in the semantic layer. So, what you're telling me is that the LLM doesn't have to do as much work.
exactly.
The LLM needs to do the work of mapping the end user's prompt into a semantic query, using the terminology, mapping to the terminology that's been defined and exposed in the semantic layer. Is that right?
Exactly. Yeah. So we are able to ask the LLM to as you said, write queries that are relevant to AtScale's single logical table that represents the semantic layer. So instead of having to pass a ton of metadata about all these individual tables that exist in the warehouse, we're able to just say, hey, we have one massive table. Just write a select statement that's relevant to this table and include the filters that are relevant to the user's question. So drastically reducing the scope of the question for the LLM into a realm where it's known to be really, really good.
Okay, so then the third problem was accuracy. Can I trust these numbers, right? And I'm just looking through the results of your paper, which you have a very nice table which just compares both with a semantic layer and without a semantic layer for the same queries against the TPCDS schema. And the TPCDS schema it's very close to my heart because I used that to do our benchmarks for performance. And it's a great retail data oriented data set that's it's a complex schema, so it's complex enough to be hard, and it's real life to be something that is trustworthy. So I'm looking at these numbers here, Jeff, and I see that that the accuracy is without an AtScale semantic layer is only 20%, but with an AtScale semantic layer, overall you showed 92.5% accuracy with really, with really only the one category where you had less than 100% accuracy. So can you talk a little bit about just how you sort of came up with those, how'd you come up with for the test? How did you develop sort of like the elements of sort of how you came up with these sort of percentages or these accuracy percentages?
Yeah. So for the question set that we fed both our control system and our LLM, and just to note, the control system we used here, again, used the same LLM that we used for our testing system, but instead of giving it AtScale semantic metadata, we gave it information about the underlying warehouse tables and all the joins that are associated with those tables. So it knew what existed, and it knew how to work with those tables in general. To evaluate the various LLMs, we had a nice system go through where user question would come in. We'd ask the LLM to translate that to, in the control system's case, directly a warehouse query. In the test system's case, an AtScale semantic query or an AtScale inbound query. Those queries were then processed either by the warehouse or AtScale respectively. In the case of a syntax error, we would ask the LLM to generate something else. So for example, if the LLM had a minor hallucination in the name of a column or something like that we could catch and we know is a hallucination based off of the existing metadata, we ask it to do something else. And just say, hey, give us a different response. So we gave it a little bit of extra wiggle room in there. But once we had a value at the end of this, so once either the control system or the evaluation system gave us a table to work with as a result, what we would do is basically look at the number of categorical columns and numeric columns in the response, get the shape of the response, take averages over all the numeric responses, and look at what the expected shape and averages are for those individual tables versus a known expected value. So basically what we would see consistently as we looked through the control was that either the control was pulling in columns that weren't relevant to the user's question. So for example, we have a number of numeric columns in this data set around sales numbers and just numbers of products sold, as well as prices and the discounts and all that. So we would frequently see that the LLM for the control would grab the incorrect column, or it would grab the correct column and it would aggregate it incorrectly. So it would give you a result for your question, but it wouldn't be an accurate result, or it wouldn't be the result that the user needed to actually deem this correct. On the AtScale side, things were a lot simpler, obviously, because the LLM just had to say, give me KPI X, and then AtScale would translate that KPI into the underlying SQL. So it ended up being that the control system struggled to define these KPIs pretty frequently. But if you look in the paper, you can see that for our lowest complexity questions that we asked it, so in the case where it didn't have to define KPIs, it did okay, actually. It got about 60% accuracy. But the second we started asking it to define KPIs or deal with joins, that number drops to at best 10%.
Yeah, and listeners, I am displaying sort of that key chart. Again, this is in the white paper. So go to atscale.com and go to resources, and you can download this for free and get all the methodology as well as these results. But what Jeff is saying is like in the case of a low question complexity, so a simple question, and low schema complexity. So you're talking about basically the number of tables, right? That would be required to satisfy the query. It's 60% is not good, Jeff. That's like that's like a little bit better than 50-50. And I wouldn't feel comfortable with relying on a system that's going to give me a little bit more than 50-50 chance that it's going to give me the right answer. And you can see that as you sort of get into the higher complexities, I mean, the high is 0%. I mean, so that's crazy. So what does high mean to you in terms of the question complexity versus the schema complexity? Can you explain that a little bit?
Yes, definitely. So high basically means that the LLM is being asked to define KPIs, and then also do an operation that requires joins across multiple tables. So you can think of the varying types of complexity as, is it just pulling a raw column from the underlying warehouse table? If so, that's a low complexity. Is it being asked to just operate off a single table, or does it have to deal with joins? That also brings it from low to high complexity, respectively. So a high basically means we're asking the LLM as complex a question as we can. It might be a join, it might require joins across 3 to 4 tables, is I think the threshold we set for high complexity. So multiple joins across multiple tables, and then also defining these complex KPIs.
Wow. So just it only takes 3 or 4 tables, Jeff, to send it to 0 without a semantic layer.
Pretty much.
Yeah, that's pretty crazy. You can, if anybody has written SQL queries before, like I have, having 3 or 4 tables send it to 0 is pretty scary. Okay, so talk to me a little bit about how does it get better? So I love the 100%. I don't love the 70%. It's definitely better than anything else we can get. But what are some of your thoughts, Jeff, for sort of where we go from here? So how do we get better? How do we get to 100% across the board, do you think?
Yeah, so the best surefire way of improving an LLM in general is to provide a training set. So as we were talking about earlier, these LLMs are really built to work off of this massive training set across the whole internet that tries to prepare for a little bit of everything. Mm-hmm. So when we're working with a generalized LLM like we are now, and we're asking it to write SQL that's only relevant to one table no matter what, we're kind of telling it to go against all this training a little bit. You can get away with that with prompt engineering and providing examples within the prompt, which we do. But the best way to do it is to give it an additional training set. And the LLM will weigh this training set a little bit more heavily. So if we really wanted this to be really rock solid and bump that 70% number up, we could provide a training set that says, hey, this is how you interact with the AtScale semantic layer. So instead of giving it 3 or 4 examples, we give it a few thousand. And we do that as a one-off. And then honestly, it ends up being better for a number of reasons. One, from performance, and second, from just a cost. You can provide the LLM less information and still have that great performance. So that would be a great way to produce some improvements. The other way to do this is to start having better interactions between the semantic layer and the LLM. So right now I mentioned that feedback loop where the LLM can get a little bit of information that, hey, we need you to recreate this or regenerate this query. We saw an error. If we can make those errors more informed and tell the LLM how to process those errors a little bit more robustly, we might be able to get that number up a bit higher as well. So those are the two main areas.
And given the fact that the semantic layer is operationalizing queries, in other words, we're seeing end users submit queries through a variety of means, through their BI tools, through their Jupyter notebooks, through applications, now through a chatbot, whether that be Teams or Slack or a prompt on an application. We also can probably use that query history data to better understand, to improve accuracy as well, right? Because we have all the explicit questions that people are asking, and then the results that we're returning. So that's pretty valuable data in itself, and it's all specific to an individual organization.
Exactly. Yeah. That's the glory of these things is as you get more information, they're meant to handle these tremendous amounts of input data. So if you just get users working with it and save all the information, it's just going to make your end product more and more powerful.
So Jeff, so this was a lot of work on creating this white paper, which I think goes a long way to sort of provide some valuable data. The methodology is all spelled out in the white paper, so I love that. You took a very scientific approach here, didn't hide anything. People can reproduce these results, especially since you can go to AtScale.com and download our developer community edition, and you can do this for free. We have the TPCDS model right there within as one of our model samples. So in Snowflake and Snowflake and other data platforms like Databricks, you also have those data sets, those TPC data sets already there for you. So it's something you can reproduce, and I encourage the industry to go out and reproduce that. So given that all this research in the white paper, I'm guessing that there's probably some product feature that this might be related to. Can you talk to us a little bit more about that?
Yeah, definitely. So the end goal of any research paper is to hopefully end up getting a product or something out of it. So the current version of this LLM is going to be included in private preview for AtScale's container August release. So it'll be working off of just a select couple LLM providers to start in a private preview capacity, but we're going to keep iterating on this and hopefully get it out to public preview and GA sometime this fall. So hopefully we'll be able to get folks using this more and more.
Well, I love it. My whole sort of point in starting the company was to provide data to anyone and everyone wherever they live, and that means sort of like providing analytics and database access to people who aren't database experts. To date, really sort of our integration with Excel was probably the most democratized, democratized interface, because anybody with Excel can query data in Databricks and Snowflake and BigQuery, all using that business-friendly semantic layer. So we really sort of opened up analytics to a lot more people with those sort of direct integrations. But what we're talking about now, Jeff, is actually inserting that back into Slack or Teams, so people can just literally write English questions and get their data. So I'm really excited about this because this means that we're now opening up analytics, not just to the Excel jockey, which there's a billion of them out there, literally a billion in the world, but anybody who really can construct a sentence. So super important research. Thank you for doing it. And I want to thank everybody for joining us today on this podcast. Like I said, go to atscale.com. You can download the white paper under resources. It's a really good read. It's a short read. It's not a lengthy read. It's really good stuff. So go and do it. And also sign up for our private preview so you can give the product a spin yourself and provide us feedback. So Jeff, thanks for all your work.
Yeah, thank you for having me.
All right. Thanks everybody, and stay data driven.